Dust jumps before the animal is fully visible. A heavy tail club cuts sideways across the frame, low to the ground, close enough to scatter grit around the legs of a large theropod. The strike does not need to land for the scene to change. The predator stops. One foot lifts, the dust cloud rolls between two bodies, and behind it, a low armored shape shifts its weight like a living fortress settling into place. Only then does the full animal appear. Ankylosaurus is not tall, not fast, and not built for a chase. Its strength is lower, wider, and stranger. The back is covered with armor. The head is broad and shielded. The body sits close to the ground, and at the end of the tail is a heavy bony club. Not a decoration, not a random lump, but part of a defensive system that only makes sense when the whole animal moves together. The simplest image is a walking tank. The better image is a locked body with a swinging weapon attached to it. That tail club was made from bone. The knob at the end formed from enlarged bony structures, and the tail leading into it was stiffened by vertebrae that supported a long handle. Like section, this matters because a club is only dangerous if the handle can transfer motion. A soft, flexible tail would absorb too much force. A stiffened tail could swing the heavy end in a controlled arc. But the club was not magic. Ankylosaurus did not simply flick it like a whip. A large club takes force to start moving, force to stop, and a stable body to keep the animal from losing balance. The legs, hips, torso, and tail had to work together. The animal could plant itself low, shift weight through the body, and swing the tail sideways. The motion was probably strongest laterally, across the ground. Level space where a predator's lower legs would be vulnerable. That is why the opening image works. A predator does not need to imagine a direct hit to understand danger. A tail club passing near the legs changes the risk. One bad step, one misjudged distance, one heavy impact against the ankle or lower limb, and the predator's hunt could become a costly injury for a large carnivore. Injury matters. A predator that cannot move well cannot hunt well. Still, we have to be careful. Fossils show the armor, the tail club bones, and the body structure. They do not show a video of exact behavior. Biomechanical studies suggest that large ankylosaurid tail clubs could produce strong impacts, and that lateral swinging was plausible. But the exact target, frequency, and real combat use remain inferred. Ankylosaurus may have used its club against predators. Related ankylosaurs may also have used tail clubs in conflicts with members of their own kind. The weapon was real. The exact scenes are reconstruction. Now look at the body again. The armor is not separate from the tail. The back plates, side protection, broad skull, low stance, and tail club all solve the same problem. How does a large, slow herbivore survive near predators that are faster and taller? Ankylosaurus did not need to outrun a threat if it could make the final approach dangerous. Armor reduces the payoff of biting. The low body reduces exposed targets. The tail creates a moving zone of risk behind and beside the animal. A predator facing this animal is not facing prey that simply waits. It is facing geometry. The armored body is hard to grip. The legs are tucked under a wide frame. The back is difficult to bite cleanly. The tail can sweep across the predator's approach path. If the predator circles, the tail can remain a problem. If the predator rushes too close, the club becomes more than a warning. The safest move may be distance. The tail club also had a growth story. Not every ankylosaurid had the same club shape or size, and younger animals may not have carried the same fully developed weapon as mature ones. That matters because the club was part of maturity, mass, and structure. A small club is not the same as a large one. A developing tail is not the same as a reinforced adult system. The defensive power of the animal likely changed through life. This makes Ankylosaurus more interesting than a cartoon tank. A tank is passive armor plus a gun. Ankylosaurus was a body plan built around trade-offs. Heavy armor costs energy. A low, broad body limits speed. A tail club adds mass that must be carried and controlled. But those costs make sense if they help the animal survive encounters where running is not the main option. Picture it at the edge of an open woodland. The animal feeds low, pushing through vegetation near a floodplain. Its body is quiet. Its armor catches light in broken plates. A predator moves nearby, not charging yet, only testing distance. Ankylosaurus does not need to panic. It turns its body slightly. The tail lifts just enough for the club to clear the ground. The hips shift, the back remains low. The predator steps in. The tail moves first. Dust bursts outward as the club sweeps across the space near the predator's legs. Maybe it strikes the ground. Maybe it misses. Maybe the predator has already pulled back. What matters is the message written in motion. This is not helpless meat beneath armor. This is a slow animal with a fast danger at the end of its body. The club might also have mattered in contests between ankylosaurs. If mature animals use tail clubs against one another, the target may not have been a predator's leg but another armored body. Some fossil evidence from related ankylosaurs has been interpreted as possible signs of combat between individuals. That does not prove every club was mainly for that purpose, and it does not erase the defensive possibility. It widens the picture. A structure can have more than one role. A weapon shaped by one pressure can still be useful in another for viewers. The predator scene is the cleanest. But evolution is rarely that simple. The tail club may have been a deterrent, a defensive weapon, a display of maturity, a tool in rival conflict, or some combination of these. Its importance comes from how strongly it changed the animal's options. Ankylosaurus did not need to be fast to be dangerous. It needed to make contact costly. The tail itself was only one part of that. Without armor, the animal would be easier to attack from above or the side. Without a low stance, the body would be easier to destabilize. Without a stiffened tail handle, the club would not move like a club. Without powerful muscles around the hips and tail base, the heavy end would be difficult to control. The weapon was not just the knob. The weapon was the whole rear half of the body working as a mechanical system. That is the key idea. The tail club was not decoration. It was not a medieval mace pasted onto a dinosaur. It was a biological structure supported by anatomy, mass, posture, and behavior. The club could turn the area behind Ankylosaurus into a danger zone. It could make a predator slow down, step back, or choose a different target. It could make another ankylosaur think carefully before closing distance. It transformed slowness into a different kind of power. The final scene returns to the dust. The predator stands close enough to see the armor, but not close enough to test it. Ankylosaurus remains low, wide, and still. Its tail is raised behind it, not swinging wildly, not behaving like a monster, only held ready. The club hangs in the air like a warning made of bone. The theropod shifts its weight, one foot steps back. Then another. The dust thins, and the predator disappears between the trees at the edge of the floodplain. Ankylosaurus does not chase. It does not need to. The armored body lowers again. The tail settles behind it. For this animal, survival was not speed. Was the ability to make the last few steps too dangerous?